Welcome back, everyone. We're going to tackle section 7.4 today, graphs of quadratic functions. Something to remember was back in unit 4, section 4.8, we defined a quadratic function as a function of the form f of x equals ax squared plus bx plus c, where a does not equal 0, and that its graph was a problem. So some key features you need to remember from back then was that if the a value, the leading coefficient, was greater than 0, then it opened up. You had the vertex point was at the lowest part of the curve and it looked like a bowl of soup. So you would have your parabola opening up and your vertex point is the lowest point of the curve. If the a value happened to be less than 0, which means it's a negative number, the parabola is going to open down. The vertex point is at the peak of the curve and it kind of looks like a rainbow. So here's our parabola opening down and at the peak is our vertex point. The other key feature of the parabolas is it has an axis of symmetry, which is a vertical line that goes through the x-coordinate of the vertex. So this dashed line, basically what it does, it splits your parabola in half. So it's kind of like a mirror image that you can fold the paper on itself. And it'll always go through the x value of the vertex. Okay, example 1, f of x equals x squared plus k. In this form of the parabola, we're going to cause a vertical shift because the x squared is our parent graph, and then the k is what's causing it to go up and down. So we're going to graph the functions on the same coordinate system. So we have f of x equals x squared, g of x equals x squared plus 1, h of x equals x squared minus 2. So back in your Algebra 1 days, when we wanted to graph, think of the f of x as the representation of the y equals. So I'm going to pick 3 corner points. So I want to know what x resulted in y. So I'm going to use -1, 0, and 1. And the reason I use those 3 values is because if I square a negative, I become positive. So there's positive 1. 0 stayed 0 and 1 stayed 1. So this is our parent, this is what we call our parent graph. So they want us to graph all 3 graphs on the same coordinate grid. So this one is our parent graph. This is the one we're going to start. See here, it's going to be that it's the same graph, only has a +1, which means this one is going to cause a shift up from the parent. This one says x squared minus 2, which means it's going to cause a shift down from the parent. You will always use the parent graph as your starting base, and then you will do your shifts from then. So what I'm going to do is I'm going to take a ruler and I'm going to do a coordinate grid here since I'm using graph paper. Label your axes. This is our x, here's our y. I'm going to start with the parent graph. The parent graph is going to be, says the ordered pairs are -1, 1, 0, 0, and 1, 1. This is why I did the t-chart here. So we have -1, positive 1, there's our first point, 0, 0, and then 1. And we just draw a curved graph going through those points. Put arrows on the end since our graph is not stopping, it is continuous. Our second graph, parent graph, says it's a shift up. Well, it shifts up 1 unit because it says +1. So all your ordered points that you just plotted, the 3 points, you're going to bump them up 1 unit. So it's going to go up 1. This one is going to go up 1. We are just rising everything up 1 unit. The y value is what's changing. I'm adding 1 to the y value. So 1 plus 1 is a 2. 0 plus 1 is a 1. 1 plus 1 is a 2 again. So here are 3 points, and again, you draw your curved lines in, and that is your g of x. The last graph we have is the second one, which is a shift down. Well, it's a shifting down 2 units, and it's the parent graph, not the orange graph, the parent graph that started at the origin. So these dots, our y-axis, are going to go down 2 units. So we're going to go down 1, 2, 1, 2, again, 1, 2. And if you notice, the distance from the point on the left to the y-axis and the point on the right to the y-axis is equidistant. Draw your graph in, That is our h of x, and our parent graph was the f of x. Another thing to remember is that the x coordinates did not change for any of our functions. The only thing that's changing is the y value. In this example, example 2, we're going to do f of x equals the parentheses x minus h closed squared. So these are known as your horizontal shifts. Again, we're going to graph the same three functions, all on the same coordinate grid. F of x is equal to x squared. G of x is now equal to the parentheses of x plus 1 closed squared. H of x is equal to parentheses x minus 2 closed squared. So again, this is our parent function here. And again, if we do our t-table, we're going to use negative 1, 0, 1. 1, we plug them in. Negative 1 squared becomes a 1, 0 is a 0, 1's a 1. Now, the difference between a vertical shift and a horizontal shift, these are your horizontal shifts. The change is on the x, so it's whatever's on the inside. So if I were to take the inside parentheses and set it equal to 0, so we have x plus 1 equal to 0, x is equal to negative 1, which means we're shifting to the left. We do it on this one, it says x minus 2 squared, so I'm going to do x minus 2 and set equal to 0. So x is equal to 2, which means we're going to shift to the right. So now since I know what is going to happen with our graph, we're going to graph our parent function again. Label your axes, x and y. Our first graph started again at negative 1, 1, 0, 0, and 1, 1. So we're going to plot our points. So negative 1, 1, 0, 0, 1, 1. And our graphs, curve your line, put arrows on the end, and label your graph. That is f of x. Our g of x equation says it's going to shift to the left 1 unit. So it means we're not affecting the y values, we're affecting the x values. So each dot is going to move, coordinate point that we've plotted already, to the left 1. So we're going to go to the left 1, to the left 1, to the left 1. And then draw your curve and label that your g of x. The last function says h of x, x minus 2 squared. So it means we're shifting to the right 2 units. So we're going back to our parent function, and each coordinate point is going to go to the right 2 units, not up. So we're going to go 2 to the right, 2 to the right, 2 to the right. And then curve your parabola in and label it your h of x. So the difference between this example and example 1 is that we're affecting, this one affects the x coordinate. Example 3. Example 3's function says f of x equals ax squared. So this is not going to be a horizontal shift or a vertical shift. This is where the graph is going to get wider or narrower. So a key point is that if the a value is greater than 1, which means it's a whole number or it can be an improper fraction, the graph will get narrower as it approaches the y-axis, which means as it approaches the y-axis, it's going to approach the y-axis getting skinnier. It says if the a value is between 0 and 1, which means it could be 1/4, 1/3, 1/7. It's a fraction that is normal. That means if I were to do it, it's going to be valued less than 1. The graph will get wider as it approaches the x-axis. So think of it as a flower opening up and blooming to the sun. So our three functions are f of x equal to x squared, g of x equals 2x squared, h of x equals 1/2 x squared. In this type of situation, if they are asking you to graph 3 functions on the same function point, pick numbers that are going to be easy for you to graph. So what I'm looking at my g of x function, and I'm looking at my h of x function. Since the h of x function says 1/2, the number I want for x has to be something I can take half of. So instead of using negative 1, 0, and 1, for the parent value, I'm going to use 2, negative 2, 0, and positive 2. to start. So if I have negative 2 and I square it, I become a positive 4. 0 squared is still 0. 2 squared is a 4. The reason I did that is now we're going to use these values into this equation. So we have, again, we're going to use those numbers. This one requires you to do your t-charts for all of them. So I'm going to put my negative 2, 0, and 2 again. Now it means I already know what the answer for plain x squared is. I'm going to take my answer and multiply by 2. So basically we're doing 4 times 2 and we have an 8. 0 times 2 and we have a 0. 4 times my 2 and we have an 8 again. When we go to this one, same situation. We're going to use the negative 2, 0, and 2. Now we're taking, think of it, it says half of x squared. So our solution was a 4 originally. So I'm going to multiply times a half. Half of 4 is a 2. 0 times a half, we are still a 0. Again, 4 times a half, we are a 2. So first thing I see is my order pairs became negative 2, 4, 0, 0, and 2, 4. That is our parent. The second one, notice that the value of a is greater than 1, so it means the values are going to approach the y-axis faster because it's approaching at a faster speed. Here, the 1/2 x squared means it's going to open up closer to the x-axis. Now, if we go to graph these on the parent graph, since my highest value for the y is an 8, I need to make sure that my graph grid goes up to an 8 at least. So I'm drawing in my graph lines. But remember, what's affected is the y value, not the x value in this situation. So I have a greater quadrant 1 and 2. Label your axes, x and y. So the first one, the parent graph, our parent. It's negative 2, 4. So I'm going to go to negative 2 on the x and up to 4. Put a dot. Still at the origin, 0, 0. And then mirror image. So if I'm 2 units out from the y-axis, I'm going to be 2 units out on the other side of the y-axis and sketch your graph line in. Never going to have a great curve here when you're doing freehand. So if it looks like a V, don't worry. On the next one, it says negative 2, positive 8. So the x value did not change. It's the y value. So right here I'm at 4. So I'm going to go 5, 6, 7. That's positive 8 here. Still at the origin. They share the same origin. 2 units out. 2 units out. Sketch your line in. That is our g of x. Don't forget to label your f of x, your parent. Now when you go to the last one, it says negative 2, 2. So negative 2 stayed here. Here's my 2. It's still at the same origin point. 2 units out. And then our graph line comes in. And we have h of x. So the more our x values increase here on the parent, on this last one, the h of x, the more the parabola is going to keep approaching the x-axis. On the g of x, the more x values we incorporate into our thing, our graph keeps getting closer and closer to the y line. You're probably wondering why we did the first 3 examples. That leads us to example 4, where it's f of x equal to a parentheses x minus h closed squared plus k. This is the vertex form. So example 1 started with a vertical shift. Example 2 started with a horizontal shift. And example 3 required us to have an a value. Now we're tying it all in together to get to the vertex form. So our problem says f of x equals 2 parentheses x minus 3 closed squared plus 4. It says identify the vertex. One thing we need to remember for the vertex, that is h comma k. Well, if we look at our equation, h is the value inside, k is the value on the outside. But we know that when we see x minus 3 and set equal to 0, x is equal to a positive 3. So we know the x coordinate is a 3. the k value stays as is, as it's 4, positive 4, I'm going to use a 4. So there's our vertex. Part B says to identify the axis of symmetry. From the beginning of the notes, I said that the axis of symmetry, it's the same as the x coordinate of the vertex. So our axis of symmetry is x equal to 3. Then it says, asks us to identify the max and minimum value. The max and minimum value, this is known as the y coordinate of the vertex. You will use the y coordinate of the vertex. So since our y coordinate is a 4, our value is a 4. Now here's the thing, we need to know, do we have a minimum or a maximum or a minimum? So in order to find out if we have a max or min, look at your A. Well, it's equal to 2, which is a positive number, which means our graph is going to open up. So we have a minimum value. The next part that we need to do is actually graph our equations. So let me switch and get graph paper and we'll continue. Okay, so we have our function as f of x equal to 2, parentheses x minus 3, closed squared plus 4. Let's remember our key features. The vertex is 3, 4. Our axis of symmetry was at x equal to 4. Our minimum value is at y equal to 4. Actually, x equal to 3 here, sorry. And then y equal to 4. So in order to graph this, you have two options. You can graph the parent function, which is what I would do, and then do your shifts. So for this one, normally our parent function would be f of x equaled to x squared. But because we already have an a value, I'm going to use f of x equal to 2x squared to be our parent. And then from here, we're going to do our shifts. So I'm going to do an XY table. And I'm going to start with basic -1, 0, 1 in this instance because it's a whole number. I don't have to worry about fractions. So -1, so basically think of it as 2 times -1 squared, which is a now positive 2. 2 times our 0 squared makes it 0. 2 times our 1 again squared makes it a 2. So this is our parent function. This is what we're starting at. Coordinate grid, label your axis, x and y. We're going to start with our first parent one, which is -1, 2. So we have a dot at -1x, positive 2y, 0, 0, and then 1, 1. So this is our, we're going to say this is our parent. I'm going to call it P of x to represent parent. And now we're going to graph our actual graph. Now, from here, we're going to have to do our shifts. So let's look at our vertex. Vertex value is x equal to 3, y value is equal to 4, which means we are going to go to the right 3 and then up 4. So each of our dots are going to go to the right 3, so we're going to go up to the right 1, 2, 3, up 4. 1, 2, 3, 4. The vertex point is going to go to the right 1, 2, 3. There's my x equal to 3, up 1, 2, 3, 4. My y component, there's my vertex at 3, 4. And the same thing here. So 1, 2, 3, up 1, 2, 3, 4. They should be mirror images. And then you do your curve. So this is our function there. There's my f of x. Now, axis of symmetry, remember, it's an imaginary dashed line going through the x coordinates. So here's my x coordinate, x equal 3. So you just have a line, a dashed line going through it, representing our axis of symmetry.